All right, everyone, let's look at the questions for the checkpoint for Module 6. So big new things here, kind of threw a lot of new concepts at you with, kind of related to set theory. So basically the questions in this checkpoint are to kind of practice with some of those definitions, some of those operations. So let's go ahead and get into it. So for question one here, I don't know if I need to write much down, so I'll explain verbally what's going on here. So three different sets I'm talking about. Set A is for the students at Chandler Gilbert. Set B is for people who drive Jeeps. So I'm not saying students, just any Jeep drivers. And C is for people who listen to Post Malone. So these are our sets. So what does A say? Or yeah, part A, not set A. But you know what? We're going to start over, aren't we? Let's open this thing in something where I can actually draw. The only thing I know that Microsoft Edge is useful for. All right. If you're an Edge user, I apologize. But what does part A here say? So this symbol right here, that U, that cup, that stands for the union. So basically, what does A union B mean? That means the things that are either in A or in B, and that includes the things that are in both. So what is A union B? A union B is the set of people who are students at CGCC, or people who drive Jeeps, or people who do both. So we've talked a lot about these Venn diagram things. So let's say we have a Venn diagram like this. So here's set A, here's set B, and here's set C. A, B, C, and then I'll just call capital X, like basically let's say that X is all the people in the entire world. Because there could be people who don't fit into A, B, or C. Like what if I'm an ASU student who drives a Toyota and I don't listen to Post Malone? Well, then I'm going to be out here. So that's what that universal set is. It's something we've talked about as well. But what A union B is it's these two things here. Anything that lands in either A or B and possibly both. So students at CGCC or people who drive Jeeps or both. And that's a big idea. Like there's a lot of what's baked into the way most people, probably many of you, if not all of you, when you hear the word or, we're used to the word or meaning, all right, if I give you a choice of A or B, that means you don't get to choose both. But the mathematical definition of or does allow for both. When we say A or B, it could be both. It could be A and B. All right, so moving on. What is B? So this weird like overarch. Sometimes you'll hear me call that the cap symbol. That stands for the intersection. So what is B intersect C? So those are the people who belong to set B and belong to set C. So those are the people who live in this shaded area. So they have to belong to both. So it's not just the people who drive Jeeps. It's not just the people who listen to Post Malone. Those are the people who listen to Post Malone and drive Jeeps. They have to do both to belong in that set there. So that's the first two. And then what is this little tick mark here? What does this apostrophe represent? So B apostrophe, that apostrophe means complement. So B complement. So what is a complement of a set? So basically a complement of a set are the people who are not in that set. Basically the things in the universal set that are not in B. And I don't want to shade that because basically that would be everything except for this circle that I wrote for B. So who are the people in B complement? Those are people who don't drive Jeeps. Like maybe they don't drive at all. Maybe they're babies. But it's really, as long as they don't drive Jeeps, so it's like most of the world is going to be in B complement. Um, Last one, this next one is pretty complicated here. So I think a diagram is a good move here. So we have parentheses. Parentheses mean the same thing, in set theory as they do in algebra. We want to handle that operation first. So first, let's deal with, okay, we have C complement union A. So I want to shade the things that are either in C complement or in A. So C complement could be this part of B. It could be this little thing right here. It could be this. And also it could be this universal set. Like it could be anything outside here. So that's a lot of stuff. Really, all we've left out is C. So are we done? I don't know. Let's keep looking. So all I've shaded so far is C complement. So basically everything that's not in C. But I'm going to take a union of C complement with A. So that means I need to include A. So some of this stuff I ignored, I'm going to put back. So basically what I have left is, a lot of the set C is left out, but basically I'm including a lot of stuff here. So now that I have a diagram, can I describe what's going on in there? It would probably be easier to describe this in terms of what's not there. So let me see if I can do that both ways. So I'm kind of looking at my shading here. So basically, I think this set describes everyone in the world except for people who listen to Post Malone. So sorry, let me start over because I'm still trying to make sense of it too. Um, so let's start again. I think this includes everyone in the world except for people who listen to Post Malone, but don't go to CGCC because there is a little bit of this overlap between A and C that I have to watch out for. So I think that's one way to describe this. So that was kind of like I was describing the set by what's not in it. Let's try again. And by the way, there's no one of these. Like, I'm going to describe this set in a couple different ways. Neither one is more correct than the other. It's all a matter of kind of just how you choose to communicate it. But as long as you're, correct and sound, it doesn't really matter. So now let's try to describe it by what's in there. So this notation here describes, well, everything that's in A. So this set includes all CGCC students, so it includes people who are students at CGCC, or Jeep drivers, but it's not all Jeep drivers, is it? So, or Jeep drivers, I was going to say Jeep drivers who don't listen to Post Malone, but that's not even accurate because I have this region in the middle where they all intersect is included. So let's start over again. So this set includes people who are students at CGCC, or people who are Jeep drivers who either listen to Post Malone and also go to CGCC, or Jeep drivers who don't go to CGCC and don't listen to Post Malone. Or people or anybody in the world who doesn't listen to Post Malone. Yeah, I think that's a lot of connecting statements, but I think that describes everyone. I personally think the first way I described it was a lot easier to follow than the second way. So that's one of the decisions you're going to have to make when you go through these kind of set theory things is, how is it going to be easiest for you to make sense of what's happening? All right, and finally, A times B. We don't really read that as A times B. Typically, we'll read that as A cross B, but this is what's called a Cartesian product, which is not the same thing as, when you think of a product where you multiply two numbers together. A product of two sets are, I should write down something for this. So basically, what is A cross B is basically the list of these things. It's a bunch of ordered pairs that look like AB, where all the A's, the little A's, are a member of set A, and all the little B's are a member of set B. So, and it's all the possible combinations of that. So basically, how many students are there at CGCC and how many people drive Jeeps? And of course, some of those are going to be the same person. But basically, what A cross B is going to be is it's going to be a list of these like ordered pairs, where the first element of that ordered pair is a CGCC student, and the second element of that ordered pair is going to be a Jeep driver. All right, so that's all for question one. Question two. So this is a big thing we're going to do with set theory, is basically in these situations, we're going to, try to organize things and figure out like what the sets are, how many things belongs to each set. And we talk about how many things are in a set. That's the word we use for that is cardinality. So the cardinality of a set is defined as the number of elements of that set. Okay, so in a recent disc golf tournament, 500 players were competing. There were 125 women, 85 amateurs, and 315 players who were neither one of those two things. So, based on the way this question is written, I'm gonna say that the sets are this. And maybe instead of writing those down, I'll just draw a diagram to include those. So I think my universal set is going to be, I'm going to call it P. There were 500 players in this universal set. So basically the entire tournament field is 500 players. I'm going to say that set W is the number of women who competed. And set A is the number of amateurs who competed. So W, A. Okay. So I think we can probably get by with these sets. Really the fewer the better, if you're going to try to organize these. So let's see if we can get by with these. So what are the relevant sets, including an appropriate universal set? I think this is it. So I know how many total players are in this event. I know how many women there are, how many amateurs there are, and there are probably going to be some that are both. In fact, that's the last part of this question. So I want to draw a Venn diagram to organize these sets. So now let's try to figure out how many elements are in each one of these sets. So there are 315 players who are neither women nor amateurs. So how many regions of this diagram are there? Well, there's the part of set W that doesn't intersect with set A. There's the part of set A which doesn't intersect with set W. There's W intersect A, so the area in the middle here. And there's also the part of the universal set that intersects with neither W nor A. And I think that 315 is what's happening out here. There are 315 players who are neither women nor amateurs. So let's write that in kind of set theory notation here. The cardinality of P is 500. The cardinality of P actually, let's say it this way. The cardinality of W union A complement is what? So what is the set W union A? Those are the players who are either women or amateurs, maybe both. So what's the complement? Those are the players who are neither women nor amateurs. So that is what that 315 is. Which is also equal to this. It's the cardinality of the set P minus the cardinality of W union A. Okay. So now can we figure out what goes in those other three regions? So the field included 125 women. So the cardinality of W is 125. The cardinality of amateurs is equal to 85. So what is this? What is the cardinality of women plus the cardinality of amateurs? That's 125 plus 85. That's going to be 210. So can I just say that 125 goes here and 85 goes here? No, we can't, for a few reasons. One of them is that, well, if there are 315 people in this universal set outside of W and A, then there can only be 185 people within W union A, and we're heavy. We got 210. So basically, we got to figure out what goes in the middle here. So I believe that one of the things you've seen in the module here and some of the videos is this: the size of the union. The cardinality of a union will always be related to this. It's the cardinality of set one plus the cardinality of set two minus the cardinality of the intersection of those sets. And intuitively, I hope that makes sense, but here's the way I kind of make sense of it. I want to know how big these two bubbles are in my Venn diagram, right? So I would just add up how many things are in W plus how many things are in A. But the problem with that is I counted this middle area twice. So for me to make my count correct, I have to subtract whatever lives in that middle region. So do I know what the size of, or what the cardinality of W is? It's 125. Do I know what the cardinality of the amateur set is? That's 85. This cardinality of the intersection is what I'm trying to find. Do I know how big or what the cardinality is of W union A? I do, because I know that 315 players who are neither women nor amateurs were there, which means the remainder have to belong to this. So if we solve for that cardinality of that intersection, what do we get? We get 125 plus 85, which is 210, minus 185. I believe that's 25. Because I'm being extra paranoid today, let's make sure that I'm right. 210 minus 185 is indeed 25. So what did I just find? I found the thing that's going to hopefully unlock the rest of this problem for me. I know this intersection is 25. So that's going to help me figure out everything else. I know that the number of women in this tournament was 125. And I know that 25 of them were also amateur, which means the number of basically women who were not amateurs is 100. And I can do the same kind of logic with the amateur side here. How many amateurs were there? There were 85. And then 25 of them are already accounted for. So that means the remaining 60 are amateurs who are not women. So one thing we should make sure of, especially since we're kind of just getting started with this, is we should add all these numbers together and make sure their total makes sense. So if I add up 100 plus 25 plus 60 plus 315, that adds up to 500, which hopefully makes sense to you because we had 500 total players competing. So I think everything, all signs are pointing to we've done this correctly and organized everything correctly. So I think our Venn diagram is good. And then part C, how many amateur women completed in the tournament? As long as we know where to look on our Venn diagram, we can answer that question without doing any more calculations. So where are the amateur women in this diagram? Well, W, this circle here, is the set of women. A is the set of amateurs, this circle here. So the amateur women are the intersection of that set. So the answer to this final question is 25. And moving on, question 3. In a CGCC cohort of 60 students, 40 are studying business, 32 are studying engineering. Every student in the cohort is studying at least one of these two. Okay, so I don't want to say always because that makes me a little bit nervous, but it's usually a good idea to start with a Venn diagram, if only to kind of organize you and help you get started and see what's going on here. I really want the overlap to be bigger. Okay, they don't have to look good, and I'll demonstrate that by not redrawing this one. So what are my sets here? Is 2 sets even enough? Let's find out. So I have business students and I have engineering students. So I'll call that B. I'll call this E. What do I want to call the universal set of students? I'll call it C for the cohort. How about that? What you call them is not terribly important as long as you know what you're calling what, and you can stay consistent. So in a cohort of 60 students, 40 are studying business. So let's start writing down some things in set theory notation. The size of the cardinality of B is 40. The cardinality of engineering, or of E, is 32. Every student in the cohort is studying at least business or engineering. So that tells me that this universal set, so basically the complement of the union of B and E. So the complement of B union E is 0, which tells me that the cardinality of the complement of B union E is 60. So this is a shortcut we couldn't take with the last problem, because we had people that lived in this universal set, but outside of the other 2 sets that we defined. We don't have that this time. Okay. So question here, how many students are studying both engineering and business? So I think it's usually best, really regardless of what the questions are about specific parts, like specific sets in your situation, really filling out the Venn diagram is going to be the way to organize all those things and answer all those questions. So let's start filling in these regions here. So just like this last set, we had 4 regions to worry about. We have 4 regions here. One of them is already decided for it because I know that every student in this cohort is better belong to B or better belong to E. So now let's figure out. So we know that the cardinality of B is 40. The cardinality of E is 32. The cardinality of the union of B and E is 60. So basically it becomes, what can we find first? I think it's usually, I don't know if the easiest is the right word, but something I usually try to find first is the intersection. Basically, try to find the most restrictive thing. And in this case, the most restrictive thing is, all right, what is in B and in E? So those things are, those are going to be in B intersect E. So let me write down the same formula that I just wrote down a bit ago. The cardinality of the union is equal to the cardinality of set 1 plus the cardinality of set 2 minus the cardinality of whatever the intersection is. So this is the same kind of relationship that I used in the last question, but I don't think we are going to be using it in the same way, or maybe we are. What is the size of the union? That is 60. I take it back. This is the thing that we are missing is the same as last time. So the size of the union is 60. The size of set B is 40. The size of set E is 32. Which I think tells me that, all right, what is 60 minus 72? That's negative 12. So if negative 12 equals negative the cardinality of this intersection, then this cardinality has to have an intersection of 12. So I know who's taking both business and engineering. Excellent. The next thing I'm asked is how many students are studying engineering but not business? So basically what I'm asked is who's in here? Actually, let's just fill out the rest of the Venn diagram. I think it's going to be easier to move on from there. So I know that 40 people are studying business. 12 of them are already accounted for. So that means the rest are going to be studying business and not engineering. Same side of that, or same other side of that same coin. I know 32 students are studying engineering. I've already accounted for 12 of them. So the other 20 have to be out here. So how many students are studying engineering but not business? We can say that's 20, which is correct. I'll write this down in set notation. I want to know the size of this set, the cardinality of this set. Engineering intersect business complement. So who are the people who are in E but not also in B? So those are 20 in number. And I believe that's what we wanted, right? Yep. All right, so that is it for checkpoint number 6.